Hello everyone. This short presentation is a brief summary of the activities carried out in my first PhD year. My name is Alberto Moscatello and I'm doing my PhD at the Energy Department of Politecnico di Torino. The context of my research activity is the risk assessment for complex industrial plants like nuclear or offshore plants for which risk assessment procedure is mandatory. So if we look at the simple formulation of the risk, we can see that the accident simulation is one of the crucial steps for the quantitative risk assessment. So in particular, I'm dealing with the computational fluid dynamics for accident simulations, and I'm working on an alternative approach, thus permitting to find a better compromise between accuracy and computational cost. The model is called the source box accident model, and is developed to simulate high-pressure gas releases in congested environments by splitting the phenomenon in two simulations, a supersonic release in a small domain called source box, and the dispersion by coupling the two steps. So the first key activity was a sensitivity analysis on the input parameters of the source box simulation. Then SBAM was applied to different case studies. It was compared to two industrial softwares, which are the standards for industrial applications, Flux and KFX. A numerical benchmark was performed. It was developed a scaling procedure to realize the scale experiments, which are now ongoing in the C-Star wind tunnel, in which a scaled mock-up of a platform equipped with gas and flow sensor is placed. The first key result was the derivation of a linear correlation between the release pressure and the source box output. We can see also that SBAM is capable to model both flammable and or toxic gas releases, and it gives a fast evaluation of both areas, so toxic or flammable. The qualitative comparison with the two industrial software KFX and Flux shows a good agreement, confirmed also by a deeper analysis looking at some relevant quantities. The numerical benchmark shows that SBAM permits to reduce the computational time about 1/10 without introducing significant error. Then a scaling procedure through a dimensionless number linking geometry, wind velocity and release parameter was developed. Finally, a preliminary comparison of the CFD values and experimental measurements shows a good agreement, a good matching of the two sets of data. Nonetheless, a future development will be the quantification of the uncertainties due to the instrumentations, for example. So, thank you for your attention, and I hope you enjoyed my presentation.